All right, gents, here we go. Absolute value integration. So let's start with kind of the most basic example, which is just the absolute value of x. Now, if you remember, let's just maybe do a little sketch of this picture to get an idea of what's going on here. This is the kind of that v function, if you remember the 12 basic functions, right? I want to find the area from -3 to +8 of this function. And if you really kind of didn't know what to do and you want to do this by hand, you could do it with two triangles, right? Two triangles. This triangle has width here of 3 and height here actually of 3, right? So this is the point -3 comma absolute value of -3, which is 3, right? And similarly, this is going to have height 8 and width 8. So this area should end up being the area of these two triangles, which is, I guess, 9/2 plus 16/2. Excuse me, not 16/2. Half base times height, 64/2. Right, so that's what it should end up being. And how can we actually do this? Well, the way I think about it is I end up doing it with something called a sine chart, right? So if you remember sine charts from, like, I don't know, I guess the beginning of last year, we're going to take the function on the inside of the absolute value, x, right? Just that function. We're going to find its roots. It has one of them, 0. And we plug a number into x to the right of 0, and we get positive over here. Plug a number to the left of x, we get negative over here, right? So since we're putting this x into absolute value, the only things that change are the negatives, right? The positives stay the same. The positives stay the same. The negatives are the things that change. So I could write this instead as two different integrals. If I only care about the positive bit, maybe I'll highlight that in green, the positive bit, that's going to be the integral from 0 to 8, right? Here's the 8, here's the 8. And I'll get rid of the absolute value, x dx. And then this pink one, the negatives is the weird bit, right? So if we think about it, we're negative to the left of 0, right? Which means the function f occurs below the x-axis, right? It looks like this, right? So we should have negative area down there, right? But this absolute value thing says I should always have positive area. I shouldn't really be subtracting anything. So what we're going to do is in this negative region, with this -3, we'll integrate from -3 up to 0. Again, we'll do x dx, right? But this will give me a negative number. So to make it positive, what I'm going to do is I'm going to subtract it. All right? And here's the general trick. We take a peek at our function inside the absolute value. We see where it's negative and where it's positive. We subtract the negative bits and add the positive bits. So this will be, the cool thing about this is this function, I have, I guess, two of them here. We have an x, I have an x. This function will always be the same. I always have to integrate once. So this is x squared over 2 from 0 to 8 minus x squared over 2 from -3 to 0. Right, so we do this. This guy on the left is, I guess, 64/2 minus 0/2 minus 0/2 minus 9/2, which is 64/2 plus 9/2, just like we wanted from before. All right, so there's the trick. We find the roots, we make a sine chart. Whenever it's negative, we subtract. Whenever it's positive, we add. So let's try this one again. All right, we have absolute x again, so we make our sine chart for x. We get one root, it's 0. So over here we're always positive, over here we're always negative. And, well, what's going on here? Well, this guy, everything here occurs to the right of 0. Right? Everything here occurs to the right of 0. So this guy, I don't have to split it up. This is actually just 3 to 8. Everything occurs right of 0, so everything's always positive. So I'm just going to have x dx. And so I guess we can write a plus sign out in front because it's the positive bit. So this is what, x squared over 2 from 3 to 8. So this is what, 64 over 2 minus 9 over 2. Okay. Next guy's going to be the same. We make the sine chart. I mean, I guess it's the same sine chart over and over. We'll get to a different one in a second. 0 plus minus. These two numbers, however, only appear in the negative section. All right, so this will be integral from -6 to -2, x dx. But we'll have a minus sign out in front because we only live in the negative section. We don't have to do anything with the roots in this case. All right, so again, and then again we integrate. So this is negative x squared over 2 from -6 to -2. So the final answer is negative, I guess, 4 over 2 minus 36 over 2. All right. Not that bad, but let's do something maybe just a smidgen harder. Now this guy has, we got to actually figure out what the root is. So we're going to take 2x minus 7, set it equal to 0. I get x equals 7 over 2. Make my sine chart. 7 over 2. If I plug in a number right of 7 over 2 is 3.5. So I plug in like 4 into 2x minus 7. If I plug in 4 into there, I get a positive number. If I plug in, say, 0, I get a negative number. So 7 over 2 is is the root, and we're negative to the left of it, positive to the right of it. So we use the same trick we used in the first problem. 7 over 2, it does live in between these two numbers, right? Like I said, it's 3 halves. Excuse me, it's 3.5. It's between those two numbers. So I'm going to go integrate from 7 over 2 up to 7. 2x minus 7 dx. And then I'm going to subtract the negative part, right? The negative part. Integral from -8 to 7 over 2. 2x minus 7 dx. All right, and now we integrate. So this is what, x squared minus 7x from 7 over 2 to 7 minus x squared minus 7x from -8 to 7 over 2. And then we have to plug everything in. I'm not going to do that right now just to save some time, but you can plug everything in and you can get an answer. All right. Here we go. Maybe just a little bit harder. Maybe just a little bit harder. Again, we solve this thing. 3x plus 2 equals 0. X equals -2 over 3. So I make my sine chart. -2 over 3. I'll get positive over here, negative over here. And we see, right, well, these numbers have nothing to do with -2 over 3. -2 over 3 is outside of them. Both of these numbers live in the positive section. So this is going to be equal to integral 4 to 8, 3x plus 2 dx. So this is what, 3x squared over 2 plus 2x from 4 to 8. And again, you can plug those numbers in, but I'm not going to do them right now. All right, we'll kick it up a notch. Bam. So here we go. We got something just slightly more complicated. So we set it equal to 0. X squared plus 5x plus 6. Set it equal to 0. And we solve this our favorite way, quadratic formula, completing the square, factoring, whatever you want to do. And get x equals -2 and -3. Make our sine chart. Right? -3 comes before -2. And we can plug numbers in, but if you remember, this is like a happy parabola, right? The first leading coefficient is positive, so it's a smiley face, so it's going to be plus and minus plus. All right? And maybe fortunately or unfortunately, all of these, the -3 and the -2, they live in between these two numbers. All right? So if I go from, say, this is equal to the integral from -10 to -3, we'll do it in order in this case. This one's positive, so I have like a plus sign out in front that I don't have to write down because it's the first guy. And I'm going to have x squared plus 5x plus 6 dx plus, minus the integral from -3 to -2, x squared plus 5x plus 6. Why is it minus? Because this is minus. And then finally plus the integral of x squared plus 5x plus 6 dx. And this guy's going to go from -2 to +12, and it's a plus sign because that guy's a plus sign. Okay, and I guess there's that little invisible plus out there. And you just calculate those three integrals, and then you're done. All right, one more for the road. Well, two more, I guess. Same thing here. We set this equal to 0. X squared plus x minus 6 equals 0. And you get x equals -3. X equals +2. Those are my two roots. All right, make our sine chart. -3, +2. Right? And this is, again, a smiley parabola, so we're plus, minus, plus. All right? And I only want to go from 0 to 9. So this will be the integral from 0 to 2, x squared plus x minus 6 dx. And then since this guy is negative, this will be minus, because that's where the 0 and the 2 live. And then from 2 to 9, that's positive. Oops. From 2 to 9, that's positive. So we're just going to have a plus sign. Integral from 2 to 9, x squared minus x plus x minus 6 dx. All right? And then we just calculate that guy. Calculate those integrals. All right, and then finally, one more. Hold on tight. Might be a bumpy ride. I got to make a sine chart for sine x from 0 up to 2 pi. Well, that actually ends up not being that bad. If I was to make, I guess, a sine chart for sine, right? When is it 0? Well, it's 0 at 0. It's 0 again at pi. And then it's 0 again at 2 pi. That one's actually not that bad. From 0 to pi, it's positive. From pi to 2 pi, it's negative. Right? And we're only going between 0 and 2 pi. So I don't need any of the outside guys. But again, this would be negative and this would be positive if we cared about it. So we're going to integrate this thing. This is going to be equal to the integral from 0 to pi sine x, right? Because this is positive, so this is positive. And then minus the integral from pi to 2 pi sine x, because since this is negative, this also has to be negative. And we can calculate this. Well, we'll do this one, I guess. So this is negative cosine x from 0 to pi minus negative cosine x from pi to 2 pi. So what do you do? So this is negative cosine pi minus negative cosine of 0 minus negative cosine of 2 pi minus negative cosine of pi. Let's do well, we can just calculate what each of these things are. Cosine of pi is 0. So this is, no, excuse me. Cosine of pi? What is cosine of pi? Back to Desmos. Cosine of pi. Actually, I could do that. I could try pi. Cosine of pi is negative 1. So this is negative 1 minus cosine of 0 is positive 1 minus positive 1. 2 pi is also positive 1 minus positive 1. And we said pi is negative 1, so minus 1. And we got to deal with the minus signs. So this is what? 1. Minus is plus 1. Minus. This is what? Minus 1. This guy's still minus 1, and that becomes minus plus 1. These two minuses become a plus. So this is what? 2 minus 2, which is 4. All right? So, do the problems.